Good morning, ladies and gentlemen. Do you take a flight before? Do you even wonder why the airplane can fly in the air? Let's look at the diagram. This is an airfoil, a cross-sectional shape of a wing. The force of thrust produced by engine will make airplane move forwards. Drag is the force that opposes the relative motion of airfoil and has direction parallel to the airflow. Weight force is caused by the mass of wing. For lift force, according to Bernoulli law, fast-moving air have lower pressure than slow-moving air, and the upper part of airfoil has lower pressure than the lower airfoil. Hence, the wing is able to make lift. Next, let's go through some of the definitions from the topic as some of you might not familiar with them. Computational fluid dynamics (CFD) is a tool to simulate fluid flow and heat transfer and analyze their characteristics using numerical method. Flow separation means the detachment of boundary layer from the body surface. In fluid mechanics, boundary layer is a thin layer formed when viscous fluid flow over a surface. It has two types, laminar and turbulent. When air flows across the airfoil, the airflow is often no longer to follow the profile of airfoil. Flow separation occurs when the boundary layer will start to detach itself from the body surface. Subsonic means its speed is lower than speed of sound, while transonic means its speed is close to speed of sound. Hence, transonic has higher speed than subsonic. While using CFD to study the development of flow separation of airfoil, nowadays, the rapid evaluation of CFD has been driven for faster and accurate method on solving the problems related to the flow field. By using the CFD, this computer simulation able to show details and features that are difficult or impossible to measure or visualize experimentally. There are several research which are related to the development flow separation of airfoil by using CFD has been conducted. When simulating the flow over airfoil, the transitions of boundary layer from laminar flow to turbulent flow will help to determine the flow features and identify the lift and drag performance in airfoil. And what I'm going to do is to propose a project using CFD to study the effects of attack angle of airfoil on the flow separation. Also, I'm going to investigate the effects of increasing the flow speed from subsonic to transonic regions on flow separation. Before I go to methodology, let me introduce a parameter related to this project, mass number. Mass number is defined as the ratio of fluid flow velocity past a boundary to the local speed of sound. For your information, mass number of sound is equal to 1, as transonic has higher speed than subsonic flow, hence, the mass number of transonic is higher than subsonic. In this project, CFD software and Xin will be used. Both modeling and the simulation of two-dimensional laminar airfoil will be proceeded by Xin. After creating a desired geometry for airfoil, machine becomes a mass process which divides the surrounding area of airfoil into tiny elements, so that numerical analysis is able to be carried out based on the finite element method. After doing meshing, followed by the step of setup, and the last part is the simulation. How to set up? To investigate the effects of attack angle on flow separation, at the beginning of the test, the angle of incidence will be fixed at 0 degree. After that, the attack angle of airfoil will increase from 0 degree up to a full separation occurrence. Second, to study the transitions of flow from subsonic to transonic, the max number of 0.3 is applied to subsonic flow at the beginning and end up with the value of 0.7, which is belong to the transonic flow. After simulation, the flow separation will be visualized. The pressure contours and the graph of coefficient of drag and lift will begin. Here is the example of the pressure contours. In conclusion, airfoil and aerodynamic shape or drag not only applicable to the air vehicles such as aeroplane wings, but it also applicable to fluid machinery such as boat propeller, wind turbine, or water pump. All of the parameters which are used to express the characteristic of airfoil must be inspected with high precision. That's the reason why the analysis of flow over airfoil become important. That's all. Thank you for watching.